Okay, so for this homework assignment, we will be exploring uh, Lab 12, exploring unfairness in data. Now, this lab is actually a homework assignment that was assigned to one of the students in Gettysburg. As you can see, it is a Jupyter notebook, so it will be easy for me to present. It would have the data and everything, and it would show you errors. So this is the unmodified one, and as you can see, um, it's running and it shows the data. It does some manipulation, and there should be an error because this is an undone assignment. See, in the red, it's undone. Now the modified one that I created and I updated is in here called the modified exploring unfairness in data. And if you run it all the way, you can see all the way down that it runs. Okay. So, what is the purpose of this program? So, this is pretty much an introductory into collecting real world data. There's a good description that is posted on this assignment that I'll just read the first one. It is natural to assume that a model is built from real world data will inherently represent the world at large. We have to take data that we have for granted, especially when we are first getting started in data science. However, if we do not pay attention to what our data looks like, how they were collected, and what features they contain, they may unknowingly create models that propagate cultural biases and unfairness. So, pretty much what this assignment is saying is in the real world, there are certain characteristics when it comes to collecting data, whether it's a person or animals or just information in general. And we want the data to not be biased to a certain types of person or ideology. So for this example, we are gonna base it in gender. So the data that's coming in is um, is loan payments. So pretty much this is a program which will help the banks uh, give a higher chance to see if a person will be able to be approved for a loan. And this is divided into not into nine to 11 to 10 columns, and one of them is gender. And this is the one that wants to show that it's biased. And in the unmodified version, as I said before, it is not completed. There's some things that are kept out that the assignment wants us to do is to first convert the male to female to zeros and ones by using a label encoder, which is a class within Python, which would change male to one and zero. The problem I found was whether you're changing gender to male or female, usually whichever is zero or one, it is placed in a hierarchy. So one would have a higher hierarchy than the person that has a zero. So that is one of the things that I've done in the modified version, which I still did the assignment in labeling the label encoder, but I also did another concept called one hot encoder. And that technique was taught in my data science course, which pretty much just creates um, another column, another column in which instead of having zeros and ones to represent male or female under a gender column, it would have them in a separate column as a male column and a female column. And if the person is a male, it will put a one as a male and zero as a female. And if it's a female, it will put zero and male and one as a female. So let me go present that. See? as you can see it here, we removed the gender and we inputted male and female. That way, the when it's doing the calculations to provide accuracy, it would not influence as much uh, within the calculations. So if we run this, which I already did, you can see we first import the data, then we read it, and then after that we present it. So we will get rid of the loan, and I believe the past due dates, we will get rid of those, and we would continue from there. So some of the so this is the modified table, which is the loan status, principal terms, past due dates, age, education, and gender. So one of the tasks that the assignment was asking us to do is to change these strings, like paid off, high, the types of education, to something that the computer can read, which is numbers. So as you can see here, we converted into these. So the zero the zero in the loan status would be collection, one would be collection paid off, and two would be paid off. And the same for female and male and the level of educations. Just for this example, in the first example, we will change these just to see the results of the accuracy. And we would do the training using logistic regression, which is one type of a training model that they taught us in data science, but I tweaked it a little bit from what they expected us to do. So, for example, I outputted it the mean measure square error, which pretty much tells the distance between the from point to point, the margin of error. And as you can see, let me check. I did not put it. Let me put it in right now. This is the number. So this is actually a pretty good number because it's pretty close to zero. Um, it is something that they taught us that if the number is pretty much close to zero, that means the margin of error is not that big. So as we continue, we can see that the accuracy is pretty biased. It's not too biased, but it's still pretty biased on having men validation than women, and this is based on gender. And as you can see here, there is a hierarchy, as I said before, with gender male being 1 and female being 0, as you can see here. And this is the result we get. So one of the propositions initially that the program has to do is to drop the gender in general, to see to train the model being blind to gender. So as you can see here, we dropped gender, and we'll just input this information into the algorithm to check what's going on. So as you can see here, I still this was not asked, but I still inputted the validation score and everything. So as you can see, it's 90%, and it's still pretty biased, but it's a little bit more closer to each other. So that's a good thing. That's what we want in the real world application. We want something not too biased, but it's still a problem that that this application is trying to show. So this is what I did, that I modified, that I learned in my data science class, called one hot encoder. And as I said before, this was the initial data set, and as you can see, it's a gender of male and female. So we changed it into having uh, a column of female and male, and as you can see, the zeros and ones. So so for this first row, the person is a male, and the second one is a female, and there is no hierarchy, so it shouldn't be too biased, but it would change just a little bit in the in the accuracy. So again, as we see here, the scores pretty much came out to be the same, and I listed here the margin of error of all three types, and they seem to have the same. So what I've noticed in this application is that the gender does not affect the the reading, uh, coming into the uh, grabbing an application. So this is a pretty good data set that could be used in the real world. So that must mean that the gender does not influence that much into an application. So later on, it would. So this is, like I said before. It's just to demonstrate the accuracy score, which can mislead in thinking that your model is great and that your mission is to accomplish. But by digging a little bit deeper and evaluate our model's performance on each gender, um, separately, we found that it performed very differently between genders. It was biased. So this is the application I've did. Um, it's pretty interesting. This is something I would like to get more into understanding biases within data sets, and that is it for now. Thank you.